Okay, today we're going to be reviewing the standard 8.PS2.1, and this is about forces and interactions, and we're going to talk about designing and conducting investigations depicting the relationship between magnetism and electricity in electromagnets, generators, and electrical motors, emphasizing the factors that increase or diminish the electric current and the magnetic field strength. So during this, we're just going to talk about the electromagnet. We'll kind of review in our minds the electromagnets that we created, and we will talk about what makes them stronger or weaker. Remember the generator, you had an option to make one of those, and we were less successful creating the generator. And then the electrical motor, in this specifically, we'll talk about the homopolar motor that we all did, or at least attempted to do in class, and hopefully that will help with this particular standard. Just as a quick review, let's remember that magnets have two poles, north and south, that opposite poles attract, like poles repel, and that magnets are strongest at their poles. And remember that the magnetic field is the invisible area around a magnet where the magnetic force is exerted. When we talk about the electromagnet, remember this is any wire with a current running through it generates a magnetic field. And then, so this goes back to the standard. How do we strengthen it? Well, it can be strengthened in several ways. Wrapping the wire into a coil, and then the more coils that you do, the stronger it's going to be. And then you can put an iron core inside the coil and use a stronger or bigger battery. And if you remember in our class, we did experiment with wrapping the wire more times. I remember Grady brought in a big railroad spike, to get a big iron core right inside that coil, and actually brought a car battery and had a lot of wire. And if you remember, that made it super strong because we were using a stronger, bigger battery. We had a major iron core inside the coil, and then we wrapped a lot of it with wire. And so those are the three things. If you can keep those in your mind, the more extreme of a picture that you can put in your brain, the more it's going to help you to clarify and make sure you get any of these answers correct on any kind of test you might have. And then just as a refresher, here's a picture of a simple electromagnet using a little battery. They've hooked the wire on it on each end of the battery to allow the current to flow through. Notice that they have it wrapped around the nail. And so you can think to yourself, how could you make this electromagnet stronger? Well, you could use a bigger battery. You could wrap the wire more times around the nail. And remember, we are using a nail. We're not using a pencil. We're not using something that's aluminum or plastic. We're using something that is iron. We want iron because that has more of the electrons tightly packed together that can line up and be a more effective magnet. And also keep in mind with the electromagnet, they can be turned on or off, and you can actually reverse the flow by flipping the battery around. These are different to the natural magnets because natural magnets poles are permanent and they already have a set strength of what they are, and so you can't increase those or decrease them. But electromagnets can, and if you remember, we talked about electromagnets being used a lot of times at big major scrap yards. They may have a big, huge electromagnet that they can actually get turned on. It could actually lift up a car and pull it around and drop it in different places. You see magnets used on construction sites a lot, especially if someone's ever come to roof your house or anything like that where nails may have dropped down. They'll have magnets that they can roll over and pick them up. So that force is important, even though we can't see that magnetic field. It is important. But the electromagnets, may be used at scrap yards, and it's fun to understand that electricity and magnetism work together. And so you'll hear those terms throughout all of your science: electromagnetic, electromagnet, and just remember that those always work together. And then the other part of the standard was talking about motors and generators and how to make those more efficient. And if you remember, you had a choice in class. You could make the electromagnet, you could do the motor, make a little motor, or you could do the generator, in order to determine the most efficient way to make that. And the one that the students struggled with the most was making the generator. And so I just want you to keep these two uh, thoughts in mind when you think of electric motors and generators, that the electric motor is going to be turning, it's going to be moving, it's going to be mechanical. And so it needs electrical energy, and it will turn that into movement, into mechanical energy. So electric motors convert electrical energy into mechanical energy. And then electric generators are the exact opposite. They turn movement, mechanical energy into electrical energy. You may see this, like I say, in windmills. You have the big fans, the big fins that would spin with the wind, and then that's going to turn something that is going to end up creating electrical energy. So electric generators turn mechanical energy into electrical energy. Okay, we're going to look at the electric motor and the electric generator. I'm not going to play the audio. I know that doesn't come across very well, but I just want you to concentrate on the pictures and think about the few modifications that have to be take place to to make one an electric motor versus an electric generator. So I'm going to play this with the volume off. Okay, notice the electrical current is turned into a mechanical force. And then look what happens when you have a generator. These two terms just swap places. You have mechanical force being turned into electric current. The electric motor, you will see at the top, right here, we are turning electrical energy into movement to modify. They're starting to modify this to a generator. They're using something for mechanical force. And then they're going to create an electric current that's going to make the light bulb light up right there. So you can see the easy transformation between the two. And then when we talk about the motors, if you remember, we did, and I think most of you were successful at making the homopolar motor. And this one, and here are a few images. So this helps to remind you of what we did. And notice you have the battery. I believe this is a AA battery. On the bottom, remember we had one of the little round magnets. And then you wrap the wire around. Not You want to get this just to the optimum distance from the magnet to make your loop close to it. And then you'll notice that the electric current is flowing through the wire, going around the magnet. So once again, you have magnetism and electricity working together. So you have this flow. Remember, you have electric current running through a wire. You're going to have a magnetic field there. Some of you did this design. Uh, a couple of you did the heart design. That one was kind of neat to see how that was done. And remember, this is something you can do easily at home, even to show your parents. It would be a lot of fun. And then I think the most common one that we ended up doing was this design. And you know, they were really fun when you could actually get them working and that they would spin really well. And so that was a lot of fun to do. But anyway, this video was not to get too deep in depth, but just to remind you of what you would have to do to make an efficient motor. Remember, we would have to modify and work on these wires. You'd have to keep bending them, get them the right distances around, to create the optimum motor. And then, so there's always going to be some type of modification that you have to make, and you can always make things a little better. Right here's another picture. This is one that many of you did. And so that's something you can do at home. Just get the little magnet, a battery, and some wire, and you can play around with that. And then you can find ways to make it the most efficient. And if you're really feeling, um, really uh, educational, then try to do the generator. You can research how to make a little generator, come up with your own mechanical device to do that. So let's go back and look at the standard one more time. Okay, remember this was a standard 8.PS2.1 to design and conduct investigations depicting the relationship between magnetism and electricity in electromagnets, generators, and electrical motors, emphasizing the factors that increase or diminish the strength of the magnet. And I click to the next slide. Um, think about that from the electromagnet. What did you have to do to make it better? Remember the 3 points on it. You had to have the iron core and something that's has very irony, I guess you would say, has a lot of iron in it, is going to make the best core. Also, the amount of times that you wrap the wire coils around it, and then the size of the battery that you use. For the electrical motor, think about that. Obviously, the more that you can get the magnetic field spinning or moving in and out of the copper wire, uh, the more efficient electricity you're going to have. We looked at the homopolar motor, designing, what's the best design, the best balance for the magnetic field to work with that electricity. And then the generator, if you can find something that can really spin faster, that's going to create more electricity, and it's going to make that bulb light up even brighter. Anyway, that was just a quick review of this standard. If you have any questions, you can always go back to the video we did on the complete magnetism PowerPoint, and you can do some your own research on Google, and you can come up with things, and you can even show me what you have come up with, and you can send that to me. Anyway, stay safe, and I will see you on the next video. Bye-bye.